Okay, what's up, guys? Sorry I couldn't be there today, at home with some sick kids here. So, just wanted to review over simplifying radicals. We're going to use that a little bit today. So, the method I normally teach is using prime factors. So, if we want to simplify 72x cubed, we're going to break down this into prime factors. Now, that's kind of like old school method where we can do a factor tree and we can break down this into like 2 and 36, and the 6 will break down to 6 and 6. But your calculator actually also does this. So on your calculator, if you guys want to go grab one, um, if you open up a calculator page, okay, so no, I don't want to say, give me that calculator page. We're going to go to menu, number, which is choice number 2 here, and then factor. Okay, so you can also just type in on the bottom down here, FACTOR with the parentheses. And then if I type in my number, it'll give me the prime factors. So I need 3 2s and 2 3s here. So for this question, I know that this is going to be 3 2s and then 2 3s. And since this is x cubed, I would also include 3 x's. Now this is a square root, so I want to circle pairs of numbers, doubles. So there's 2 2s, 2 3s, and 2 x's. Now remember, 2 times 2 is actually 4. So what I'm really doing is taking the square root of 4. I have a square root of 2, a square root of 4, a square root of x squared. Sorry, not 4, 9. Okay, right? A square root of x squared, and then an extra square root of x here. So each of the pairs of numbers represent the product of those numbers. And then what I'm doing is taking the square roots of these numbers are actually going to get pulled out in front. Okay, so if I was doing this live right in front of you guys, I would have written a radical and putting down 3 2s, so 2, 2, 2, 2 3s, and then 3 x's. Okay, so I'm circling my doubles. So there's 2 2s, there's 2 3s, and there's 2 x's. And every double, one number comes out. This is really 4, and the square root of 4 is 2. This is the square root of 9, so a 3 comes out, and then an x comes out. And what I'm going to do, okay, is get rid of this stuff in front, is I'm going to multiply everything that's outside and everything left inside together. So x times 3 times 2 is 6x, and then there's a 2 and an x left over inside. And so this turns into 6x times the square root of 2x, okay? That's the method I normally teach, so I'm going to stick with that today. If you normally do the method where you separate 72 into a perfect square and another number that's not a perfect square, or it doesn't have any perfect square factors, then you would just reduce the square root of 36 to get that. So working through the first one, if you can take the square root of a number, you know it's a perfect square root of 100, then I know this is just going to be 10, okay? But if I forgot, right, 100, if you want to bust out your calculator here, right? So menu, number factor, 100, you can see is 2 2s and 2 5s. So 2 2s and 2 5s, okay? And then I'm going to circle my doubles. Notice I'm circling everything. So there's a 2 that comes out, a 5 that comes out, and then there's nothing left on the inside. So 5 times 2 is 10. So 2 radical 20. If we want to break out the old factor tree, we can do that as well. So if you don't have a calculator, and you can see this is going to turn into a 2 in front, 2 2s inside, and a 5. So I'm going to circle my 2s. I bring 1 2 out front, and these 2s are gone. There's a 2 times 2 out here, which is really 4, and there's a square root of 5 left over. Okay, the square root of 28, right, is 4 times 7, which breaks down to 2 times 2. So this becomes 2 times 2 times 7, so 2 2s and a 7. There's my set of 2s, so I bring a 2 out front. All right, so let's see if you guys can do the next set, and then I'll put up the answers in a second. All right, so I'm pausing the video, so you do the work. Pause it now, and then check it when you unpause it. Ready? Pause. All right, so the first one, right, broke down into 3 2s and a 13. So we circle a set of 2s, which becomes 2, and then radical 26 left over. 99 becomes 2 3s and an 11. The 3s come out. Oh, don't do that. The 3s come out. So we get a 3 out front. Okay. So the square root of 3 times 3 is really 9, right? Square root of 9 is 3. And then we have an 11 left inside the radical. And the same thing here. Okay, we're going to move out the 75 is 5, 5, and 3. We pull the 5s out. Bring one of the 5s out, I should say. And that gives us 5 radical 3. All right. You can see in letter G here, and give me a second while I shift this up, that I have a negative 3 in front. So that negative 3, remember, is going to stay in front. And then I'm going to bring in any other factors from the 48. So remember the 48, right? 6 and 8, 2 and 3, 4 and 2, and then the 2's. Or if you want to break out your calculator, okay? So 48, 4 2's and a 3, right? 4 2's and a 3. 1, 2, 3, 4, and a 3. Remember, we're technically multiplying those together. So I circle my doubles. There's 2 of them. So I'm going to bring 2 2's in here. So there's really 2 times 2 times 3, right, which is 12. But it's negative 3. So negative 12 radical 3. Now, an easy way to check this is you type in your original radical. So negative 3 control square root 48. It's going to give me a crazy decimal, okay? If my answer, negative 12 radical 3, matches that crazy decimal, then I know that I did this correctly, okay? And you can see that I can't simplify 3 anymore, so I know that that's in simplest radical form, all right? So we have 108 and 150, so I can do the same thing here. Go up and highlight, hit enter. All right, 108 is 2 2's and 3 3's. 2 2's, 3 3's, circle, circle. Okay, bring out a 2, bring out a 3. 2 times 3 is 6, right? So 2 times 3 radical 3. And then this is 6 radical 3. Okay. Same thing for 150. So factor 150 is 2 3 and then 2 5's. So 2, 3, 5, and 5. Circle my set of 5's. Bring out 1. And then 2 times 3 is 6. And there's my answer. That's simplifying radicals, guys. All right, on to the next page. This is just a review, so I'm going to go through a couple questions here and there, not the whole thing. You guys can finish, and then I'll send you a video of all the answers later today, okay? So on the first one, remember we have the altitude drawn to the hypotenuse. We brought our one right triangle, and we drew this altitude and created 3 right triangles now, okay? So remember the rule, we have to draw 3 triangles that look just like the original, of getting progressively smaller in size, okay? And if we need to, we can label them. So remember, this one is I, K, M. The medium one has a right angle at G. The short leg goes over to I, and the longer leg goes over to M. And then it's a right angle at G, short leg at K, and it extends out to I. All right, so if KG is 9, IG is 12, find the length of IM. So we're going to call this X. So we're going to label, okay? So in the really big triangle, I know IM is X and that's it, okay? And I'm going to label this in blue so we don't get confused here. So give me a second just to switch over to blue, all right? So X here. The small triangle, we have a hypotenuse of X. The medium triangle, I should say, the hypotenuse is X and the short leg IG is 12. And in the small triangle over here, okay, I have a longer leg of 12 and a shorter leg of 9. And you can see I don't have anything that's corresponding. Like I have these two, right, the 12 and the X here, which are the hypotenuse and the short leg, but I don't have this guy and I need it, but I can find it, right, because it's a right triangle. So I can do a squared plus b squared equals c squared, and I can get this, okay? So if I plug in 9 squared, and plug in 12 for a and b, okay? And we can do it on the calculator. So 9 squared plus 12 squared is 225, and the square root of 225 is 15. So this is 225 take the square root, and now I know that this side is 15. And now I can do my proportion. So 12 from the bigger triangle over 9 from the smaller is equal to x from the medium triangle over 15. And I cross multiply. 9 times x is 9x, and 12 times 15, 150, about 180 we're going to say, but we'll do it anyways. 12 times 15. What's up? All right, divide up by 9, and we get 20 is equal to x. And remember, it asks us for the length of IM, so let's answer that question. IM is x, so it is indeed 20. Okay, so remember, whenever you see the altitude hypotenuse, or you see this picture, we're drawing out the 3 triangles, we're labeling. If we have to use Pythagorean theorem to figure out a side we would need, we can. Okay, and number 2 is the same type of question. They want to know what h is that will make this right triangle. So they're just asking if the altitude is drawn, which it is, right? That means we have right angles here and here. Okay, we want to figure out h. So if ut is 12, and RT, which is this whole line, is 42, that would make this, right, the difference between those two, and that would turn this into 30. Okay, so we want to figure out h. Once again, we're going to draw out our 3 triangles, okay, getting progressively smaller. So I'm trying to draw this. They're going backwards on me. There we go. 1, 2, and 3. All right, and we can label. So this is S, T, R. The right angle now is at U, and it's US, R, and then U again, and then this one is a short leg to T and a longer leg to S. Okay, so in the really big triangle, the only thing we have here, switch colors, is this is 42. In the medium-sized triangle, we have a short leg of H, right? And a longer leg RU, which is right here, of 30. And in the smaller triangle, we have this is 12, and then this is H. So you can see I have these corresponding pieces, and so I can make a proportion. So 30 from the medium over H from the small is equal to H over 12. So H times H is 8 squared. 30 times 12. Break it out if you need to. Okay, it's 360. And if we try to take the square root, what happens? It doesn't work. And so what we want to do is leave this in simplest radical form. So let's factor this out. Get some extra practice here. So we're going to hit menu, number, factor, 360. And it tells us it's 2 3s. Sorry, 3 2s, 2 3s, and a 5. So in my radical, okay, 3 2s, 2 3s, and a 5. Okay. So I'm going to go ahead and circle my doubles. So there's 2 2s here, and there's 2 3s. I'm going to pull those out. So this becomes 2 times 3. So this is 6 outside, and 2 times 5 is 10 inside. And 6 radical 10 would be my simplest radical form. Okay, do some work, kiddo. All right, going on to the next one. Remember, in these 2 triangles, if the diagram below shows the 2 triangles are similar, that means that these 2 angles are going to be equal, okay, because they're in the corresponding positions here. So just set them equal and solve, okay. Same thing for number 4. If the triangles are similar, now we have sides. So this means we're going to set up a proportion to solve for number 4. I'll leave you guys to do that one. All right. Number 5 is another one that we just talked about, very similar. So draw out your 3 triangles, okay? 3 triangles. Remember, draw that chopped out, stretched out triangle. Progressive getting smaller, okay? Well, I said smaller and then I drew that thing. All right. Okay, so you can see like in this triangle I have X and 20, and we can label for ourselves J, E, H, Here's K, J, H, and then K, E, and J. And so I have 20 in there. In the small triangle, I have a hypotenuse of 20 and a longer leg of 16. And there's my, and I can solve, okay? All right, in these questions, we're going to be doing just two similar triangles and set up a proportion. So these word problem questions, we're just going to take our corresponding side lengths here, okay, and then set up a proportion between the two sides. So in the tree, the height is h, the wall has a height of 4, and that's equal to the shadow of the tree, which is 24 over 6, and then we just cross multiply and solve. I'll leave you guys to do the cross multiply, okay? Number 7, same type of question, just draw a diagram. So the flagpole and then the nearby building, two similar triangles again. The same thing with number 8, okay? Number 8 is also a similar triangle question, okay? The accompanying diagram shows the section of the city of Tacoma. High and Road Street and Main Street are drawn 5 miles apart, and they're parallel. Ridge is perpendicular here, okay, through, and the distance between the intersection of Ridge Road and State Street is 12 miles. So this distance right here is 12 miles, okay? What is the distance between the intersection of Ridge Road and Main Street, where the railroad tracks cross Main Street? So I want to figure out this guy. And so if you guys are looking at this, really I'm talking about these two similar triangles, if you see them, and I need to create a proportion between them. So we know that this is 5 and 12. This whole thing, though, is 10 and x, and then you can go ahead and solve that one. Okay, I'm going to leave you guys to try number 9, also number 10, and then that's it for this guy. So hopefully the video helps you guys get started, and I will see you guys tomorrow.